Hope everybody's doing okay. Today I'm on my laptop, using my iPad just because I'm going to be doing some stuff with the graphing calculator. So if you have that, you should definitely get that out. I'll show you some things that you can do on there. Um, and then if not, if that's like at school or something, you can certainly follow along in Desmos or something like that. Um, So we're starting just some application problems with sinusoids, trying to come up with the graph and things like that. So I'm just going to work through a couple of these examples with you. They're pretty straightforward, and then we can move on from there. Okay. Um, so the first one says that you have a weight that's on a spring that bounces at a maximum of 8 inches above and below an equilibrium point. The time to complete one cycle is 2 seconds. Okay. Um, Now, when it's talking about bouncing at a maximum of 8 inches above and below, okay, that's referring to the amplitude, right? So if you can think about what sine and cosine look like on a graph, right? They would, they go up to the highest point and then down to the lowest point. Okay, so that is referring to the amplitude. All right. Now it says the equilibrium point is at 0. Okay, so that's where your axis would be, your principal axis. Okay, and then it says for the time to complete one cycle is 2 seconds. So that's referring to the period. Okay. So it says to draw a graph to show the motion of the weight going in 4 seconds. Okay, so you can imagine what this looks like, right? If you have the weight, right, is 8 inches above, right, and then you drop it, it falls down to the bottom, and then it springs back up, and then it springs back down again, and it keeps following that pattern. Okay, so we're going to draw our axis first. All right, so this is going to be in time. All right. Now it says that, actually, let me change that a little bit. So we're going to go 8 inches above and 8 inches below. Okay. Now it says that the period is 2 seconds. Okay. So the period is equaling to 2. Right? So what I should go up by on my horizontal axis, right, is going to be 1/2 to get my period, right? So this is going to be 1/2, 1, 3/2, 2, and then we're going to do 2 periods. So 5/2, 3, 7/2. And then 4. Okay. Now it says, I would imagine if if you're dropping a weight that's on a spring, right, you're going to drop it at the highest point. Okay, so that means what we're going to start at +8, right, and then we're going to drop it. So after a half of second, it should be at the middle ground, and then after a second, it's going to be at the lowest point. Okay, and then back to 3/2, and then after 2 seconds, it's back where it started, right? And that's what the problem is telling me. Okay, so then we're just going to repeat that process for another cycle. Okay, and then you just need to connect the points to draw the graph. Okay, so you have your graph now, right? Now what it's asking is to write 2 equations to describe the motion of what the weight is doing. Okay, now looking at what you have, right, it's pretty obvious that you can start with the cosine curve. All right, so we already know that the amplitude is 8. Okay, now the period we know is 2 seconds, so that makes that the b term is going to be pi, okay? And then we know that our axis is 0, so we don't actually need to write that. Okay, so we're going to do one cosine and then one sine curve, okay? So if I start with this point up here at the top, right, this is going to be y equals 8 cosine of pi x, okay? And then if I start with this point here, right, at 1/2, right, that's the sine curve, right, because we're starting at the axis. Okay, so that's going to be y equals -8 sine of pi, and then x minus 1/2 because of the shift. Okay, so if we needed to do other questions based off of this graph, right, we could use either one and we would get the answers. Okay. All right, so for number 2, we're going to be using the calculator now. So it says you're on a Ferris wheel that has a diameter of 40 feet. Okay, when the last seat is filled and the ride begins, it takes 4 seconds for you to reach the top of the wheel, which is 43 feet above the ground. The wheel makes 1 revolution every 8 seconds. Okay, so we have, imagine you're on the Ferris wheel. Fancy Ferris wheel that I have. Okay, now it says the top is 43 feet above the ground. Okay, so that's 43 feet. Now it says that the Ferris wheel has a diameter. The diameter is 40 feet. Okay, so that means that this equation, or this Ferris wheel actually, is 3 feet off the ground. Okay, so your lowest point is at 3, and your highest point is at 43. Okay, and then 1 revolution is 8 seconds. All right, so that's going to refer to the period, right? So what we want to do, right, is it says we want to sketch the graph of this. All right, so I'm going to put t as time, right? Now we're just going to do one cycle for right now, and then if we need to extend that, we certainly could. Okay, so if you're getting on at the bottom, right, that's going to make your 3 feet above the ground, okay? And then the highest point is 43 feet, okay? So the diameter of the wheel is 40 feet, right? The difference between the two, okay? Now, if you go in the middle of that, right, what would be in the middle of 43 and 3, right? So if you subtract the 2, right, you're going to get 40. If you divide that in half, you get 20, right? So if you add 20 to the lowest point, you're going to get 23, okay? So that's going to be where your axis is. Okay? Now it also says that it takes 8 seconds for you to go around one whole time, okay? So if my period is 8 seconds, that means my interval should be 2 seconds. I'm going to go just an interval of 2, 4, 6, 8. Okay? So imagine, again, you're getting on the ride, right? So you're going to get on the lowest seat, and you're getting on at 0 seconds, right? So after 2 seconds, you're in the middle. Okay? After 4 seconds, you're all the way up to the top. And then after 6, you're back to the middle. And then after 8, you're back to the bottom. Okay, so this is your curve that you're talking about. All right, so that's one cycle for the function. Okay, now it says we want to write 2 equations based off of what's going on here. Okay, now we already said that the the distance from the lowest point to the highest point is 40, right? 43 minus 3 is going to be 40. Now, if you divide that in half, you get 20. Okay, so the amplitude is 20, or half of the diameter of the wheel. Okay, so that's going to be A. Now your axis is at 23, right? The middle ground. Okay, so the value for D is going to be 23. Okay, now the period is 8 seconds. Okay, so then that makes then the B term is going to be 2 pi over 8, or pi over 4. Okay, so first equation that I can do, we'll call this F of t for Ferris wheel. All right. Now, because you're starting at the low point there at 0, 3, right, this is a negative cosine. So it's negative 20 cosine, the B term, pi over 4t plus 23. Okay, so that's referring to that point right there. Okay, and then if I wrote a different equation, right, so f of t, okay, I could do 20 sine pi over 4, and then the shift is just 2 over 2 seconds, so t minus 2 plus 23. Okay, and that would be referring to that point there. Okay, so it just depends on the point that you pick to start. Now, because we're going to use this to kind of solve it, what I'm going to do is I'm going to type in this first equation into my calculator. Okay, so I'm going to clear that. I'm going to go to y equals, and I'm going to type that in. Okay, now first thing you guys make sure that you do is you're going to put in, make sure that it's in radians. Okay, so I got negative 20 cosine of, so I'm going to do this, so pi divided by 4. Now you can just do x, you don't have to do t. And then we're going to close this, and then plus 23. Okay. Now what I want to do is I want to change my window so that it looks like what I just drew on my paper. Okay, so go to window now, and we're going to go from, say we'll do 0 to 9 seconds, or 0 to 10 is fine. That's all right. Just so you see the whole graph, and then the min for the y terms, I would go from like -1 and then go up to like 45. So I'm just going a little bit higher, just so that I see my whole graph. Okay, and then you can hit graph. All right, so as you can see, right, we have what we just drew, right, on our paper was that first cycle there. Okay, now for part C, it says, when is the first time you are exactly 30 feet above the ground? Okay, so what you're trying to do is you're trying to figure out, when does my equation, when does it equal 30 feet? Okay, or when does it cross 30 feet? All right, so what you guys can do on your calculators is you go back to y equals, and you type in 30. Okay, and then you're going to hit graph. So it's asking for when is the first time that you hit 30, okay, which is right there, right where that intersection occurs. Now to figure that out, what you're going to do, you're going to hit second, and then the calc menu, which is the trace button, and then you're going to go down to number 5 for intersect. So 5. Now this blinking X comes up, right? So what we're going to do is we're going to move that over so that it's closer to where the intersection is. Okay, and then from there, you just hit enter 3 times. 1, 2, 3. Okay, so your answer is this X value right here. So after 2.455 seconds, that's when it hits 30 feet above the ground. Okay, so t is 2.455 seconds to reach 30 feet above the ground. Okay, and then the last question is determine the total time that you are above 30 feet for the first rotation. Okay, and what we have on our calculators, this is the first rotation, right? Obviously you can keep going, all right, but we're only doing the first rotation. So the time that you're above 30 is the first time that you hit 30, right? And then you reach the top of the wheel, and then now you're coming back down, okay? So whenever you hit this part, that's when you stop being above 30 seconds, okay? So we already have the first answer. Now I just need to find the second one. So I'm going to hit second, calc, go to number 5 again, and then you're going to go to where the second point is. Okay, just move it closer to where, again, it's intersecting, and then hit enter 3 times. So 1, 2, 3. Okay. So we have 5.545 seconds. Okay. So again, we're doing f of t equaling 30. So time 1, we already figured out, was 2.455 seconds. Okay, and then time 2, we just figured out was 5.545 seconds. Okay, so the total time, I'll go back to my paper now. The total time is going to be the second time minus the first time. All right, so we got 5.545 minus 2.455. And if I do that on my calculator, I get 3.09 seconds. Okay, so you are above 30 feet for a total of 3.09 seconds in your first rotation. Okay, and then the last one, number 3, says that scientists find that populations of some kind of predatory animals vary periodically, assuming that the population of bears in a certain forest varies sinusoidally with time. Records started being kept when t equals 0 years. A minimum number, 200 bears, occurred when t equals 2.9 years. The next maximum, 800 bears, occurred at 5.1 years. Okay, so we're going to use this information here. So 200 bears when you reach 2.9, and then you have 800 at 5.1. Okay, so just use the information that you have in front of you. All right, so even though we started tracking when t was 0, okay, the first point that we have was after 2.9 years, okay, and that was at 200. Okay, so this is population. All right, so we'll call this P of t, population of bears. Okay, and then this down here is time in seconds. Not seconds, sorry. Years. Okay, so the first one, right, after 2.9 years, we know that there's 200 bears, okay? And then it says the next maximum is 800 bears at 5.1 years, okay? So 5.1, we have 800, okay? Now, how do we come up with the other points, okay? Now, 2.9 is a low point, and then 5.1 is a high point, okay? Now I need an axis value in between that, another axis value, and another low point. Okay, now if you guys do the math, right, you do 5.1 minus 2.9, That's 2.2 years, okay? All right, what does that represent, right? That's half of the period, or half of the cycle, okay? So the full cycle, right, should just be double of that, right? So 2.2 times 2 is going to be 4.4. So this whole cycle takes 4.4 years to complete, right? Okay. Now, if I divide that by 4, I get 1.1, right? So what I'm going to do is I'm going to go up by 1.1. So 2.9 plus 1.1 is 4. 4 plus 1.1 is 5.1. Okay. And then another 1.1 is 6.2. And then another 1.1 is 7.3. All right. Now, you're going from 200 to 800 bears, right? What would be the middle of that? So the difference between the two is 600. Divide that in half, you get 300, right? So 200 plus 300 is 500. So that is going to be your axis point, okay? So you're going low, axis, high, axis, back down to the low, okay? So that is your curve for this bear population, okay? So what we're going to do again is we're going to write an equation, all right? So we know that the amplitude, right, we know is 300, okay? The middle ground of our graph, right, was 500. So 300 to the highest point, 300 to the lowest point. So our amplitude is 300. We figured out that the period was 4.4, okay? So to figure out the b term, I'm going to do 2 pi divided by 4.4, okay? So if I do that on my calculator, right, now I'm going to quit. I'm going to do 2 divided by 4.4. Okay, I get that number. Now if I hit math and then hit enter for fraction, that gives me 5 over 11. So 5 pi over 11 is going to be the b term. Okay, and then the axis we know is at 500. Okay, so this first point, right, we're going to say P of t is going to be 300 cosine. Now it's going to be negative 300, right, because we're starting at a low point. 5 pi over 11 t minus 2.9 plus 300. Oh, sorry, plus 500. Okay, so you can use that equation, or if you wanted to use the higher point, you can do P of t is 300 sine 5 pi over 11 t minus 4 plus 500. So either equation should work out fine. Okay, I'm going to use the first one. So I'm going to put this first equation into my calculator. So let's get rid of that. Let's get rid of this. Let's get rid of that. So I have negative 300 cosine. Oop, wrong one. Negative 300 cosine. Okay, so I'm going to put a fraction. So I got 5 pi over 11. And then x minus 2.9, close that, plus 500. All right, so if I go to my graph now, or no, I'm going to change my window. Go to your window. So you're going to go from like 0, we'll do like 7.5, a little bit higher than what our graph is. And then we'll go from like -1 to about 810, because that'll be a little bit more. Okay, so we started right over here, right? So this is one cycle. We're starting at the bottom and we went up. So here, and then we were going back down. Okay, so even though we didn't draw this other part here, that's okay. We have the bottom part and then going from there. Okay, so for question C, it says determine the population after 7 years. So you're doing P of 7 equals what, right? So when you go to your graph now, what you can do is hit just trace, okay, and then just type in 7, because that's the x value that you want, and then just hit enter. And that says that there are, we'll round to the nearest, so this will be 227 bears. So after 7 years, there are 227 bears in the forest. Okay, and then the last question says, bears are declared to be an endangered species when their population drops below 300 bears. Determine between which values of t were the bears first endangered. Okay, so between which values were the bears first endangered? Okay, so what we're going to be looking for is when does it drop below 300, okay? So go back to your calculator now, and you're going to go to y equals, and you need to type in 300. Okay, and then you're going to hit graph. All right, so this is when they started tracking the population, is when it was at 0. Okay, so when does it hit below 300, right, which is right here. Okay, so it's asking between which values of t were the bears first endangered. Okay, so you know, how many years were they first, how long were they first endangered? Okay, so we need to figure out this point, and we need to figure out the second point. Okay, so you're going to hit second, calc, go to number 5, and just get it closer to where that first point is, and hit enter 3 times. Okay, so the first time is after 2.311 years. Okay, and then we're going to hit, do it again. So second, trace, go to number 5, and then get it closer. Just hit enter 3 times now. So 1, 2, 3. So the second time is going to be 3.489 years. Okay, so I wrote that down, right? So now it just says determine between which values were the bears first endangered. Okay, so I'll just answer the question. So bears were first endangered between t equals 2.311 years and t equals 3.489 years. Okay, and then you could also say the total time that they were endangered you just do that math real quick. So 1.178 years. Okay, and that's it for applications, right? So again, it's just trying to pick out the information, and writing the equation. It'll always look like a sine or a cosine graph. All right. You're just gonna have to look for, little clues about, how long does the cycle take to complete? How high and how low does it go, and then everything else is pretty straightforward from there. So if you guys have any questions, let me know. Okay. Thanks.